Hello everyone. In this presentation, I'm going to present the XBRL agent, my financial agent that I built for the XBRL's internal agentic building week. First, an overview of what is XBRL. So this is a universally accepted standard for digital business reporting. It's used worldwide for financial data exchange, especially by banking and regulators. It's a standard that exists over the last 20 years for global business reporting. So there are a lot of potential for the use of LLMs in the analysis of these reports. First, to enhance the efficiency in generating financial insights and also to improve the accessibility of the information to the public. However, LLMs, they have some kinds of limitations. The first of them is their limited knowledge in the financial domain and also for up-to-date information. Because as you may know, LLMs just have information of facts that happen up to the day of their training. Another problem is that they struggle to do arithmetic and mathematical operations. To solve this gap, there was this paper from 2024 by some researchers from Columbia that aims to address these LLM limitations, proposing an agent, right, that it's equipped with specialized tools for the analysis of XBR data. Here, our project is to develop something similar to this paper, using this paper as a reference, but using the aiXplain framework for developing the agent. This is the paper that we use as reference, right, is XBRL Agent, leveraging large language models for financial report analysis. The paper, as they describe, aims to respond to 4 kinds of questions, right? The first one is answer questions about financial terms, such as XBRL terms like abstract, facts, and so on. The second kind of questions is to answer domain queries with information that is on XBR reports, such as what is the cash flow for Nike in the forward year of 2023. The third kind of questions is questions that actually require knowledge of financial math, such as a project expects annual cash flows of $6,000 for 4 years. If the discount rate is 8%, what is the net present value? Okay, so they expect the agent to answer this kind of questions. And the fourth kind of questions is the ones that actually combine domain knowledge that can be found in XBR reports, and based on these reports to also perform financial formulas, right? So this is the case. What is the forward 2015 unadjusted EBITDA margin of Netflix? And they ask here to calculate the unadjusted EBITDA using unadjusted operating income and the EA. Based on this, what the agent needs to go, it's go through XBRL reports, find the information there, right, about the EBITDA margin for Netflix, and based on this, perform some mathematical operations to get into the final number. Here to do this, we developed an agent that it's basically a GPT-4o large language model that has at their disposal 4 tools. The first tool is an information retrieval one that we just trained with XBRL terms. Another one, it's also an information retrieval with financial formulas. The third one, it's an information retrieval index with financial facts. And the fourth one is a Python interpreter tool, such as the agent can execute Python code. So here I'm going to show to you how the demo looks like. Okay, here's how my agent looks like. Let me go forward cell by cell so you can understand how this agent was built and how they can be executed. So the first thing we will do is to actually install the software development kit by aiXplain in Python by pip install aiXplain. Then I'm going to go ahead and actually register my team API key in aiXplain. And also here, I have the path for the 3 data sets that it's proposed on the paper, right? That I'm going to use actually to index the data for the XBRL terminology, for the financial formulas, and also the finance bench data set for the financial reports. So let's go over how this data was indexed. So aiXplain has their own solution for creating information retrieval system that it's called AIR. and this can be used through our XBRL. So basically what I did here is to actually first start with training the information retrieval systems for the XBRL terminology. So we load the data set, and then from there we select two columns, the one that has like the term and the one that has the explanation. And then what we did, we generated actually XBRL records, right? Documents that we would like to index, concatenating these two information, the term and the explanation. So we generate the documents. Then we go ahead and we create this indexing. So it's called XBRL terminology. We give a description. Here I already created the index, so I'm gonna just instantiate. But if I was like creating the index from the beginning, what I would do here, it's actually to add these documents, to index these documents in batches of like 10 for each time. But once this terminology, all the documents, it's indexed, I can actually retrieve similar documents to any question, such as this one. What is a dividend, right? So if we take a look, here I'm going to see that with a similarity of 93% on the information retrieval I trained, the most similar document is this one, that the term is dividends, and the explanation is actually the explanation for the term. So pretty convenient, right? This is what we would expect for. So same thing we did for the financial formulas. We actually load the data set provided in the paper. We actually extract the column formula name, the one that actually has the mathematical formula, and the one that has the explanation. We generate the records, concatenating these documents. Then here is how we would create actually the index, right? Using the index factory, and I would give a name, a description. This index was already created, so I'm going to just instantiate by their asset ID. Okay. Here I would do the same. I would actually index the documents in the data set by batches of 100, but this is already done. So I'm going to just like try, and let's say I have a question like, what is the net present value formula? So if I run this, the most similar document would be the net present value. I would have the mathematical formula and their explanation. So as far as convenient. And followed, I would do the same for Finance Bench, where I have actually several financial reports for a number of companies that is provided in this paper. On the data set that they provide, we actually selected 3 information to be indexed. That it's the doc name, that contains the name of the company, the doc period, and the evidence text. Okay, so this is the information that we actually index. We use as metadata also the doc name, doc period, doc link, page number, and question type. Then we also create the index, and we do the indexing of this document. Since this was already done, again, I'm going to just actually instantiate the index, and then here I can try, right? I know that this data set has information about the report of 2015 by Amazon, so I'm going to just actually ask for something. And then if we see here, we have like a couple documents, such as like the one from Amazon on 2017, the one from Amazon on 2019, and there it goes, right? So I have like a couple documents, not exactly from 2015, right? But it's similar. So there it goes. So now that I have the 3 agents, I'm ready to actually create my agent itself. So this is how we did. We give this instruction to the agent. We say that the agent is an expert in finance and can answer questions about finance statements. And given a question, I want them to follow these steps. So first, extract financial formulas in the formula index. To skip this step if no formulas are mentioned. I want them to extract terms in the XBRL terminology index. Skip this step if no terms are mentioned. And I also want them to extract mentioned facts in the question and search for their explanation in the financial index. This step should not be skipped. And then, like I do a condition here. If no math is involved, response to the question if the most relevant information found. Now, if math is involved, use the Python interpreter to calculate the answer. And based on this, respond the question in a friendly and concise manner. And actually here I put a note to make it clear that this always perform these steps in the order they are presenting before respond. And then the agent is actually created like this with the 4 tools. with like our information retrieval systems we created and the Python interpreter too. So they are already created. Here in the case, I'm just instantiated. And if I take a look, I can go there and answer like some questions. Those are cherry-picked examples, right? So let's say I ask what is the DPO of Amazon in the fourth year of 2017. So I would expect that the answer is 93.86 days. So let's see. So there it goes. So Amazon's for the year's DPO is 93.86 days. So we can see that the answer was actually answered correctly. And then we can actually audit to see if the agent would take the steps that we would expect to. So we can check the intermediate steps. And here we can see, for instance, on the 2 steps that it first looked for Amazon for the year 17 DPO, and then it got some similar documents. After this, it also searched for financial facts like the Amazon Ford 17 accounts payable. And if we take a look forward, yeah, so based on these 2 informations, right, later it called the Python interpreter to actually calculate the information based on the documents that it found. So here we have another question that is like for financial formula. Let's say I have a starting investment of $2,000, annual interest rate of 3% for a duration of 10 years. What will be the future value for this investment? So if we take a look, so the future value investment would be 2,687.83. So this is the answer is correct. Let's see the intermediate steps that the agent follow. So here we can see that the first thing it did, it was actually look for what its future value on the XBRL formula index, right? So it found here the formula, their mathematical notation and their explanation. And based on this, it manages to write some piece of code that was executed by the Python interpreter to generate the final response. So here you can get a bit of like the flavor on how this agent works, right? This is publicly available and you can try by yourself. And we are happy to know your opinion about if you have suggestions, comments, and so on. So have a nice day.